Congratulations on your purchase of a Sniper EFI system. The Sniper EFI system is compatible with several popular ignition configurations. In this video, I'm going to show you how to properly wire and set up the system for a magnetic pickup distributor using the ECU to control your ignition timing. All timing advance as well as retard functions will be performed by the ECU. This ignition option starts with a timing control specific magnetic pickup distributor or a magnetic pickup distributor that has had the advance properly locked out. It will also require a phasable ignition rotor as well as a Sniper coil driver or a CD box as well as a compatible coil. The ECU needs to receive a clean input signal, and vehicles that have excessive electromagnetic interference or RF issues can compromise these signals, as well as other critical control circuits resulting in poor performance or drivability issues. Proper grounds, spark plugs, ignition wires, and wire routing are all critical for a trouble-free operation. Non-resistor spark plugs and solid core ignition wires may have worked great on your carburetor, but they will not work with EFI. A common sign of trouble will be if your radio whines when the engine's running. If you have EMI or RF issues, they need to be corrected before proceeding. You will need to install and properly phase the distributor pickup and a rotor before proceeding. There are a couple ways to perform this task, and I'm going to show you the way that I have found to be the easiest to follow with great success. Before you get started, you'll need to disconnect the negative battery terminal and remove the fuel pump relay. Before we can sync our distributor in place, we need to get the crankshaft in a proper position first. We need to make sure that we're bringing it up on the #1 cylinder's compression stroke. There's a couple ways you can go about doing this. One of the methods is to take out the #1 spark plug, stick your finger in the hole, and rotate the engine in the direction of crank rotation. And as you're approaching #1, you can feel pressure release. The other thing that you can use, and it's one of my favorite little tools, is this top dead center whistle. You screw it in place of the #1 spark plug, and as you're rotating around and you're approaching top dead center, you'll hear it whistle. The reason I like this is not only does it make it a little bit easier to tell when you're on compression stroke, a lot of times you can't get your hand down in there while you're trying to run a breaker bar or ratchet. It's also a good way to confirm whether or not your pointer and your top dead center mark align, because as it approaches and it hits top dead center, it's actually going to stop whistling. At that point, we're at top dead center. We can check to make sure that our 0 mark on our balancer properly aligns with the 0 mark on our timing pointer. If not, we need to figure out why. It could simply be that you've got an aftermarket timing pointer that doesn't align with the factory balancer or the brand balancer you have. It could also mean that the balancer's outer shell over time has slipped. It's kind of lost traction with the elastomer between the center hub and the outer shell. If that's the case, you really want to replace that balancer before you proceed any further. From this point, we need to mark out the balancer. We need to have a reference point at 45 degrees before top dead center. Now, if your balancer is not marked out, don't worry about it. You can do some simple math and determine where it needs to be. You can take and measure the diameter of the balancer and multiply the diameter times 3.14, and then take that total and divide it by 360. When you get that total divided by 360, multiply it times 45, that's how many degrees we need to be beyond 0, and you can measure that distance out with a tape measure around the crankshaft. Or what I like to do is just measure that on a piece of masking tape, and you can stick it to the balancer. It makes it a little bit easier to see and a little bit easier to do that. I'm going to go grab a piece of masking tape, and I'll be right back. So I got a piece of masking tape, and I took the dimensions for 45 degrees that I figured out, and I marked them. While I was at it, I also calculated it for 15 degrees as well as 30, and you'll know why here in a little bit when we go to phase that distributor in. So I'm simply going to line up my 0 on my top dead center mark and apply that piece of tape. I now want to bring my crankshaft around to the 45 degree mark, and this is going to be our reference point for our magnetic pickup distributor. Now that I've got this in place, I'm not going to move the crank anymore. I'm going to go ahead, I'm going to remove my old distributor and get my new distributor ready for installation. We have our crankshaft set at our desired pickup point. We need to remove the old distributor. We've got the wires and everything removed, but before you pull that distributor out, it's a good idea to take some compressed air and blow out and clean around the distributor. The last thing that you want to do is pull this old distributor out and have a bunch of debris fall down in your engine. When we've got our old distributor out, we can get ready to install our new magnetic pickup distributor. We go to install our distributor, you want to do a couple things first. First thing you want to do is do a dry fit of the distributor without a gasket on the base. And that's to make sure that it possibly doesn't bottom out on your oil pump drive, which could cause some severe engine damage. In order to do that, you simply drop the distributor in and make sure that the distributor body fully seats against its mating surface. If you installed the distributor and it was raised slightly, that would indicate that you have an issue. The common cause of that would be if the cylinder heads, the intake manifold, or the block has been machined. When you do that, it's going to reduce some of the tolerances and it'll make the fit to your pump drive a little bit tighter. If your distributor has an adjustable slip collar, you can just readjust it at this time to make sure you have ample clearance. If not, a simple trick that you can do a lot of times to shim it up is to install a second gasket, and it'll act as a shim to help hold that distributor up. Once you've confirmed that you've got adequate clearance and it's not bottoming out, you can go ahead and install the distributor. You want to make sure that the distributor gear is compatible with your camshaft. Depending on the type of cam you have, you may need to go with a bronze gear. If you're not sure, check with your cam manufacturer and they can give you the proper recommendation. If this distributor's already been run in the engine and it's been broken in and seated to the camshaft, you're going to start the engine right away. You can simply coat it with a liberal amount of engine oil. If it's never been run in before, the engine's not going to be put back into service immediately, you want to go ahead and coat that gear with a generous amount of Holley lubricant. Once you've got that ready, go ahead and install the gasket and we can install the distributor. You want to be conscientious when you go to install the distributor and look at the orientation of your rotor pointer. You want to make sure that the rotor is pointing in the general vicinity that you want the #1 tower to be on from the spark plug. If it's not pointing in the right direction that you desire, you can simply lift it out, readjust it a couple teeth, and drop it back in. If you have a distributor that interferes with a bracket or something on the body, it could be one of these bosses sticking out. Don't get too worked up about it. You could simply just pull everything out again and readjust it. Move it out of the way. Once you've got the rotor in the position that you want it to be in, roughly for #1, you need to align the pickup pole with one of the reluctor wheels. So we'll look down here. We get that lined up right with the reluctor wheel. At that point, I'm going to go ahead and I'm going to lock the distributor down. I'm going to reinstall my hold down and I'm going to tighten that up. At this point, my pickup is phased correctly for my 45-degree reference angle. However, my rotor is not. So we need to phase the ignition rotor. There's a couple ways to go about this. A street car is going to be a little bit different than a race car. If you're phasing the rotor on a street car that really has a varying range of timing, what I would suggest doing is look at the minimum amount of timing and the maximum amount of timing and divide it in half. For my little small block here, I'm just going to say that I'm going to have a minimum amount of timing of 20 degrees and a maximum amount of timing of 40. If I split the two, I'd end up with 30. Now, if you have a race car, it can be a little bit different. You're probably going to want to look at where the critical timing occurs. It might be a naturally aspirated engine where peak timing and peak power occur at 38 degrees, and that's where you want it to be set. It could also be a nitrous or a turbo engine, and maybe your peak critical point on the high end of the track where it really matters is only 11, 10, 12 degrees, something small. You would want to phase and line up the rotor at that point. Since I'm going to do this at 30, I'm going to come around to the front of my engine and I'm going to rotate the crankshaft to my 30-degree mark, which was my midpoint on my timing curve. From here, I need to phase my rotor. So to properly align and phase my rotor, I'm going to come back to the back of the engine. I'm going to look at the orientation that the rotor is pointing. I'm going to grab my distributor cap. One of the things that's handy is if you have a old distributor cap laying around, is to actually drill some ports in it, some holes that allow you to view, and that's going to actually be a nice little tool to aid in proper rotor phasing. I'm going to take my distributor cap, I'm going to drop it in place. I'm going to see what tower I can look down in there is closest to that rotor. I can remove the cap and I can make an adjustment to that rotor to line it up. I can reinstall the cap and I can look down through those handy viewports and see if it's aligned. I actually need to make a little bit of a small adjustment back to it. And that is perfectly aligned with my tower that I'm going to utilize for number 1. At this point, I'm just going to go ahead and I'm going to snug that rotor lockdown. At this time, I can go ahead and install the distributor cap that I intend to use. I can reinstall my ignition wires. This is a really good time to go buy a new set of wires and a new set of plugs and put a fresh set in before you proceed. No use at this point with all your investment and time of going ahead and putting an old set of wires and plugs back in the engine. Once we've got that complete, we're going to need to go into the software, the handheld wizard, and we're going to want to set up the proper ignition type. So through the setup wizard or through the ignition setup tab or the software, you'll want to select your ignition input type as magnetic. We'll want to go in and program the reference angle at 45 degrees and the inductive delay we want to set at 60 as a baseline and put the dwell time at 2 milliseconds. Once that's been programmed in, we can go ahead and do some initial wiring. You're going to have a magnetic pickup lead coming out of the ECU. It's going to have a green wire as well as a purple wire, and they're going to be marked crank positive input and crank negative input, and you will find a matching connector on your magnetic pickup distributor. Just install those and make sure that they are fully engaged. From that point, you're going to need to have the ECU send a output trigger to whatever's going to control your coil. You're going to look at the input-output harness and you're going to look for the solid white wire that if you look at it closely, it's going to say points output. We'll take the white point output trigger wire and we'll connect it to our ignition driver that's going to drive our coil. If I'm going to hook it up to the Sniper coil driver, I'm going to find the white wire coming out of the coil driver and I'm going to connect it. From there, I'm going to take the gray wire and I'm going to connect it to the negative side of the coil, and the positive side of the coil will go to a switch 12-volt source. That switch 12-volt source needs to be tied to the ignition run side of the ignition switch. That side will have power during key on as well as crank. If you accidentally wire it to the accessory side of the ignition switch, it's going to shut off during crank, and while we know how that's going to work, it's not going to start the engine. If we're going to use a CD box, in this case our 6425 MSD Digital 6AL, we're going to find the white wire in the ignition box, which is going to be labeled a point input trigger, and we're going to connect our point output trigger from the ECU to that wire. When you're dealing with a CD box, there will be a dedicated power and ground. In the case of our MSD box, the orange wire is going to be positive and the black wire is going to be negative, and you will hook those directly to the coil. When you're dealing with a CD type of ignition system, never under any circumstances hook the yellow wire up to the TAC output of the MSD box or to the coil. If you connect the yellow wire to the system with a CD ignition, you're guaranteed you're going to destroy your ECU, so you just don't want to do that. With our phasing complete, our wiring complete, we're going to go over to the vehicle and do some pre-startup checks. I'm going to reinstall the negative cable to the battery, but I'm not going to put the fuel pump relay in yet. We're going to do a couple initial checks before we get to that step. So we'll go on over, we'll take a look at the car, and we'll go one step further. Before we try to start this engine, we want to do some pre-start checks. One of the things that we want to do is confirm that we not only have the distributor synced correctly, we want to make sure it's wired properly, and also we want to make sure that it is set up properly in the ECU. To make sure that it's properly wired and properly set up, we're going to go ahead and look at our monitor on our handheld and pull up one of the values that says RPM. And with just a key on, it should say stall. When we crank it, it should show RPM if everything was done properly. So it's showing RPM, so we know that we have it wired correctly and set up properly. At this point, we want to go ahead and check our timing. We want to make sure that it is phased correctly. One of the ways to do that is we want to enable a static timing check. So we can go back out to our home screen, and we will go under Tuning, System, and Static Timing. At this point, we can program in a value. I usually like to use 15 degrees, so we can adjust our slider over and then fine tune it with the arrows to 15 degrees, and we want to hit set. At this point, we're going to get out and we're going to check it with the timing light and make sure that it's at 15 degrees. If you shut the ignition off for any reason, as a note, keep in mind that when you do that, it will actually clear this out automatically. So if you shut the ignition off before you do your static timing check, you're going to need to go in and reset it. So with it set at this point, we're going to go ahead and we're going to check the initial cranking time, and we're going to make sure that it's at 15 degrees. We've got our static timing check set at 15 degrees in our software, or our handheld. Now we just need to double check that timing by just cranking it over while we still have the fuel pump relay removed. Go ahead and crank it. All right. So our timing's at 15 degrees. We're right where we need to be. If you find that when you crank it over, the timing is off a little bit, just make very small adjustments to the distributor as required to make sure that that's at 15 degrees. We got that set up. We can go ahead and reinstall our fuel pump relay. We'll try to get this thing started. With the fuel pump relay reinstalled, we're going to reset our static timing check to 15 degrees. We're going to try to start the engine. We're going to confirm where the timing is. Go ahead and try to start it. Go ahead and bring the RPM up a little bit. Hey, so you may be wondering why we checked the timing and I had my buddy rev the engine up a little bit. We're going to explain that to you. We checked it initially at an idle, and I confirmed that my timing was at my 15 degrees where we set our static timing check. And I had him rev the engine up safely as high as you could generally go, and I wanted to make sure that my timing didn't move at higher RPM. If you find that your timing varies when you free rev the engine, you're going to need to go in and correct that utilizing the inductive delay. If you make changes to the inductive delay, you're going to have to shut the ignition off and back on for those changes to take effect. If you find that the timing is retarded, you're going to need to go in and actually advance the inductive delay setting, and you need to increase it. If you find that it's advancing at higher RPM, you're going to need to go in and reduce that value. I recommend changing that value in units no greater than 20, and then you can fine tune it as required based on your engine combination. The base settings in the software are pretty close, and you usually don't need to change those, but as we know, every engine combination is different, and you may need to go in and modify those, and we give you the ability to do that. If you shut the ignition off and back on, one thing to keep note of is that you will clear out your static timing check. Once that clears, you will need to go in and reset that before you check your timing again. Once you're happy with it, you can go in and program your timing curve as required for your engine combination. It's important to double check this and make sure your timing's right, because the last thing you want to do is detonate the engine. It may seem like a lot of redundant checks, but it's worth every second that you spend doing it. Once you're happy with your timing setup, it's time to go out and drive the car and enjoy the new benefits you have of computer-controlled timing. For more Sniper tech tips and videos, go to Holley.com.